So our final problem on this is a regression problem. Here we have three different possible regression models. So a exponential regression can take the form of an exponential, which looks like we would expect it. It could have a logarithmic shape, but there is also a third option that is called a logistic model. And what a logistic model basically does is it's almost a combination of the two. It's a model that starts off looking very slow. It has a very high growth rate for some determined amount of time, and then eventually the population of whatever you are analyzing actually stops growing and becomes more static. And so when we have this type of shape, this is called a logistic model. And when you look at your data, if you see this type of rapid growth and then flattening, you would use the logistic model to graph it. And the logistic model is just in your list of regression options like everything else in every other regression problem that we've done. So let's real quick just take a look at this particular model. So this problem reads that the percent of the U.S. population that uses the internet cell phones is given in the table. So in 2003 it was 2%, in 2004 it was 4.5%, da 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 da. So we're going to take this data and we are going to take our handy dandy calculator and we are going to input that data into the calculator. So take your calculator, stat, edit. I'm going to put all of my x values into list 1 and all of my y values into list 2. So my data is now entered into the calculator. Oh, I have a mistake. I see that 6.8 should be a 66.8. So let me change that real quick. Bam. Alright, so that's fixed. Now I'm going to y equals. I'm going to clear out whatever I've got in here. I'm going to go into my plot, turn it on. I'm going to hit zoom 9, which is zoom stat. And there is my model. Now this is that logarithmic idea that I was telling you about. See how it goes up and then it looks like and then the curve flattens. It starts to flatten out instead of continuing to go up. So it's got kind of that up and then flattening shape to it. So I'm going to use a logistic model. So I hit stat, calc, and I just arrow down. There's a logarithmic regression. There's exponential regression. I keep going. There's logistic. I hit enter. L1, L2. I'm going to store it. Alpha NY1. And I'm going to calculate. And it takes the calculator a couple seconds because the logistic model is pretty complicated. Alright, so here is my logistic model. I'm going to write that down on the paper, and then we'll talk about it. But let's real quick graph that and see if that actually is a good model, and see how it's going up, and then it starts to flatten back out. So it's got that S shape to it. All right, that logistic model. There's a rough sketch of our scatter plot. Now, the information that the calculator spit out basically equates to this equation right here. And it's really, we only look at logistic modeling very, very briefly. You don't need to know all that much about it. This C value, that 99.7, that is actually the value that it flattens out at over time. If you notice, and this is all you really need to notice about logistic modeling, is that this is a decreasing function. So this part of the denominator is going to 0 as x gets bigger and bigger and bigger. So as x approaches infinity, this part will go to 0, which means the denominator goes to 1. And so the 99.7 is the value that this thing will eventually approach. So over the long term, this will slowly but surely become close to 99.7, which is just under 100. And if we look at what this problem is actually about, which is U.S. cell phone usage, it makes sense that cell phone usage cannot actually go up over 100%. So eventually 99.7% of people will use cell phones, in the long run. So as far as the questions go, determine the appropriate type of question. That was logistic. We talked about the graph. We made the model. The variables are the year, and I used years since 2000, and percent of cell phone usage would be the Y. In what year is the percentage expected to exceed 97% for the first time? So all we have to do is be able to read the calculator to do that. And Y equals, I'm just going to go ahead and put that 97, just like we would for any other one. 97 goes into B. So let's regraph this thing. And we still see this, and we're going up. And then our 97 is going to come in there. And so we need to go out a little bit more. So we're going to zoom out. Zoom 3. So now we get a wider vision of what we've got. Here comes that red line. And now we just need to figure out when these two things intersect. So second calc, intersect, first graph, second graph, guess. And so that intersection happens at 12.8, so right about 13 years. So 2013. And that is the review for your test. Have a good evening, and see you.